Hello students, we are learning lesson number 9, force and laws of motion, and today we are going to solve certain problem sums which are already solved in the textbook, but we are going to understand its calculations properly. See the page number 124 of your textbook, and this is example 9.6, and this is video 10 of the chapter. A bullet of mass 20 gram is horizontally fired with a velocity of 150 meter per second. ms raised to minus 1 raised to minus 1 means per second. So bullet is fired with a velocity of 150 meter per second from a pistol of mass 2 kg. So mass of the bullet is 20 gram, mass of the pistol is 2 kg, and the bullet is fired with a velocity of 150 meter per second. That is the velocity of the bullet. What is the recoil velocity of the pistol? Recoil velocity means when the bullet moves in the forward direction, that is action, and then the pistol will be moving in the backward direction, that is the reaction. So with what velocity the pistol moves in the backward direction, that is called recoil velocity. Recoil velocity. For this, two objects are there. One is bullet, one is pistol. So we are going to write two datas this way. See, these all the sums are based on the law of conservation of momentum, whatever I am going to explain you now. First one is 9.6 as I was explaining. Data of the bullet, that is object 1, then data of the pistol, object 2. Data of the bullet is mass 1, mass of the bullet. The m1 is 20 gram. So always convert gram into kg. So 20 upon 1000, 0 gets cancelled, so we'll get 0.02 kg. U1 is 0. Why U1 is 0? Because bullet is at rest as well as pistol is also at rest. So U1 is 0 and bullet is fired with 150 meter per second. So V1 is 150 meter per second. Now the data of the pistol. M2 is 2 kg as given in the sum. Mass of the pistol is 2 kg. U2 is 0 because pistol was also at rest. And now the velocity of the pistol means with what velocity the pistol will be moving in the backward direction, that is the recoil velocity of the pistol we have to find out. So dash and then do question marks. Now for applying the moment, that is law of conservation of momentum, we know the law. According to the law, it is total momentum after collision is equal to total momentum before collision. First of all, we are going to find the total momentum of the pistol and the bullet before fire, means before collision. It is m1 u1 plus m2 u2. So m1 is 0.02 into u1 is, this is 0, plus m2 is 2 and u2 is 0. So we'll get this number multiplied by 0 is 0 plus 2 into multiplied by 0 is 0. So the answer is 0 kg meter per second. That is unit of momentum is kg meter per second. The total momenta after the fire, that is m1 v1 mass into final velocity plus mass of the second object into final velocity of the second object. So m1 is 0.02, it is given, into v1 is 150 c plus 2v2, m2 is 2 and then v2. So 0.02 means 2 upon 100 into 150, 0 gets cancelled. So we are getting here 3 plus 2 v2. How 3? 15 to the 30 upon 10. 0 gets cancelled. So it is 3 plus 2 v2. Now applying the law of conservation of momentum, total momenta after collision is equal to total momenta before collision. So total momenta after collision, this one, after fire is 3 plus 2 v2 is equal to total momenta before collision, that we got 0. So 3 plus 2 v2 is equal to 0. So we are going to get 2v2 is equal to this 3 on the right hand side, that is minus 3. So v2 is minus 3 upon 2. If you divide 3 by 2, we get 1.5 and minus sign is there. The minus sign indicates that the bullet was moving in the forward direction while the pistol is moving in the opposite direction, that is opposite direction, so it is minus 1.5. The recoil velocity, you can write the answer, recoil velocity from right to left is minus 1.5 meter per second. So this was the sum, example 9.6, and they have explained the textbook with, that is before firing both of them were at rest, and after firing the bullet is going in the forward direction with 150 meter per second and the pistol is moving in the backward direction, that is the recoil velocity. So recoil velocity we have found out. Now see the next sum in your textbook, page 125, example 9.7. We will read it. A girl of mass 40 kg jumps with a horizontal velocity of 5 meter per second. So a girl is having the mass 40 kg and the cart was at rest, and the girl jumps on the cart with the velocity of 5 meter per second. See the picture. She is jumping. Her mass is 40 kg. She is jumping on the stationary cart with 5 meter per second velocity. So in the question it is asked that mass of the cart is given. The mass of the cart is 3 kg. What is her velocity as the cart starts moving? When she jumps on the cart, as the cart is lighter in weight and it is having the wheel, so she will move along with the cart. The cart will move. There is the action. And the cart will move, so the girl is also going to move. So what is the velocity of the girl? Actually, while the cart also moves and the girl also moves, then the velocity of both the objects, that is the girl and the cart, will be the same. So final velocity of the girl, if it is v, then the final velocity of the cart will also be v. We have to write the two datas, that is data of the girl as well as data of the cart. So this way we are going to write. See, girl is mass 40 kg, m1 40 kg, and u1, she is jumping with 5 meter per second. u1 is 5 meter per second, and v1, that is the final velocity, will be v. Now cart means we have assumed this to be v. Then cart mass is 3 kg, that is m2, that is the second object mass. m2 is 3 kg and u2 is 0 because cart is at rest, and v2 is equal to v. Both the velocities you see it is same because both of them are going to move together. Now the final velocity of the girl and the cart is same as the girl jumps on the cart and moves along with the cart. Again we have two datas we are having, so law of conservation of momentum we can apply. Total momentum of the girl and the cart before collision is m1 u1 plus m2 u2. Now you have to place the values from the data. You are having m1 is 40 and u1 is 5 plus m2 is 3 and u2 is 0. That is, if we calculate, it is 200 kg plus 3 into 0 is 0. So 200 kg meter per second. While writing, you can also write 40 kg into velocity is meter per second. So the unit becomes kg meter per second. Or you can write it directly as the unit of the momentum is kg meter per second. Total momentum of the girl and the cart after collision. That is m1 v1 mass into final velocity plus mass into final velocity of the cart. So m1, now v1 and v2. What is v1? That is also v, and v2 is v. So for both the cases we are going to write m1v plus m2v. Now v1 and v2 is equal to v. So here v will be common. So take it out of the bracket. We'll write v, and inside the bracket m1 plus m2 is remaining. So now write the values of m1 and m2. m1 is 40 kg and m2 is 3 kg. 40 plus 3v, we get 43v. That is total momentum before collision. Similarly, and total momentum after collision, or before collision and after collision, we have found out. That is, before collision is 200 kg and after collision is 43v. Applying the law of conservation of momentum, we know total momentum before collision, that is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Now place the value of this calculation. In this calculation we had got 200 kg. So 200 is equal to 43. One of the values is 43v. From 1 and 2 we get 43v is equal to 200. So v is equal to 200 upon 43. Now dividing 200 by 43, let us see the division, how it is done. See, 200 is divided by 43. First of all, how to guess? We don't know the table of 43. If we don't know the table of 43, we can assume that we are dividing the number by 4. If we divide the number by 4, not 43, then we'll take 20. So it will be 4 5s are 20. That means we can try with 43 5s. If I get 43 5s, it is 215 for 200. That is more than 200. So you take the previous number. That is 43 4s, we got 172. So I took 43 4s is 172. You can do the multiplication this way. And then it is 172. So 200 minus 172. That is 0 minus 2. Here 28 we are getting. After getting 28, put a decimal number and get 0. So we got 280. Now again 4 7s. If we take 28, divide by 4. 4 7s 28. So 43 7s I have tried. It is 301. That is more than 280. So I got 43 6. It's 258. So 43 6 is 258. By subtraction we got 22. Again 1 0 we have taken. So 220. That means 4 5s are 20 is possible. So 43 5s are, I got 215. And 43 6 is already more than 220, so I am going to get 215. So 43 5s is 215. Subtract, we got 5, take on 0. Then again 43 1s is 43. Then we got 7. So go up to 3 decimals this way. And after going up to 3 decimal, we are going to write up to 2 decimal by taking the approximate value. 4.651. Approximate value means up to 2 decimal. Now the second number is 5 and the third number, we have to retain up to the second number. So see the third number is 1. If the third number is 5 or more than 5, then we have to add plus 1 with the previous number in approximate value. But if it is less than 5, then keep the number as it is. So it is 4.65. Suppose the number would have been 4.657 or 4.655. Then this would have been 4.66 because the third number is 5 or more than 5. That way it would have been. So 9.7 example is 4. For today only this much. We'll be meeting in the next video.